presentation, we'll go over the double arrow in rule, and then we'll go over the first set of practice problems. If you remember, I've told you on multiple occasions that a double arrow is really just this. It's one conditional and the other conditional. So the double arrow in is pretty easy. The basic problem for this would be something like this. So we don't really need to derive anything in this one. It would just be the two premises and then the conclusion. Like so. It'd be 1 and 2, double arrow in, then 2. Now, with double arrow, it's sort of like our other wedge in rule, where it doesn't matter which side we put things. So if I were to tell you to prove this instead, it's the same exact proof, just flipping the two statements around in the conclusion. So it's the same thing. As long as you have two conditionals, you can write the biconditional with either sentence on either side, or and so again, this is the most basic version of it, so let's do some tougher problems. Here in number 1, we see that the conclusion is a double arrow, and this is just a good rule of thumb. Whenever you're doing a double arrow, it's good to remind yourself that you are looking for P, or not always looking for P arrow Q, but in this instance, we're looking for both conditionals. So we're looking for those. And imagine if you were trying to prove those conditionals, you'd have to assume the left-hand side and prove the right-hand side. Now in these first couple problems, we won't get that involved. They'll be pretty easy because, as you'll see, P arrow Q, we already have it. And then we're looking for Q arrow P, and we already have it. So we just need to get those two separate, and then we can do the double arrow in with what we've got. And luckily, this one won't take too much time because we can take our P in 3, toss it into the conditional statement in 2 to get our Q arrow P out. So that's from 2 and 3, arrow out, 2 and 3. And now we've got both of our conditionals, so we can just double arrow in. So this first one's pretty easy, and we just need to cite our two conditional statements. Double arrow in, and 1, 2, and 3. These other ones we don't need. But this one's pretty easy. Like I said, we're just looking for those two conditionals. We get them, double arrow in. So our conclusion in this second problem is Q double arrow T. So we know we're looking for Q arrow T, and we're looking for T arrow Q. So we already have T arrow Q here, and we already have Q arrow T here. So we probably won't have to do our assume the left-hand side and derive the right-hand side. This one will be pretty easy. And again, we see that we're just bound up with a conditional statement here in 1. If we wedge in our P on S, we can get the antecedent for the conditional statement in line 1. We can derive the conditional statement Q arrow T in line 5 from 1's our conditional statement, 4's our antecedent. We're doing arrow out, so 1 and 3. Now we got both of our conditional statements, so we can double arrow in. Very easy. They will get more difficult as we go. Here we need to cite 2, 5, double arrow in, 2 and 5's, 1, 2, and 3. Scratch those out. So that's the second one. Here on 3, we're looking for S arrow P and T, and we're looking for P and T, arrow S. So we have P and T arrow S here in 1, but we don't have our S arrow P and T. So now we're going to have to prove, so this one's already good. We need to prove our S arrow P and T. How do you prove a conditional statement? Well, you assume the left-hand side is a PA, and you look to derive the consequence, so in this case it's P and T. So we assume S, toss it into 2, so that's from 2 and 4, arrow out. And now we're looking for P and T, so we can put P and T together from 3 and 5, ampersand N. 3 and 5s to 3 and 4. Now we've got P and T. It depends upon our PA and 4, so we can P arrow, oh, not P, sorry. It is S arrow P and T. So that's from 3 and 6, arrow N. Remember, with arrow N, you drop out the PA that's associated with it, so we won't write the number 4 there. Now we've got the other conditional statement we're looking for, so we just double arrow in. And that would be from 1 and 7, double arrow in. 1, 2, and 3. Don't need these other ones. So, as you saw in this one, we had this at the beginning, but we needed to prove the other conditional statement. And how do you prove the conditional statement? You assume the left-hand side, and you look to derive the right-hand side. So it's a proof within a proof, sort of. And most of the ones that we'll do from here on out will be structured this way. So here again, we have a biconditional as our conclusion. So we're looking for this, and we're looking for this. Luckily, we already have that second one there. So we're just looking for the first one. So we need to assume the left-hand side and look to prove the right-hand side. So if we assume S, here's a PA in 3. We can toss that into the conditional statement in 1 to get 1 and 3, arrow out. Now we just need to wedge in our T on 4. And with that, we can build our conditional statement that we're looking for from 3, 5, arrow in. And so that will be from 1 and 3. We are dropping out the 3 because we're doing arrow in. And so now we got both of our conditional statements. We can introduce the double arrow there. So that would be from 2 and 6, double arrow in. 2 and 6 is 1 and 2. Other numbers not needed. So that's problem 4. Here on 5, we got another just simple double arrow, so we know we're looking for that. And we're looking this. We have T arrow P there, so we're all good with that one. Do we have P arrow T? Well, we don't yet, so we need to assume the left-hand side as a PA and look to prove the right-hand side. This one's pretty easy too, because we could just toss that into the first conditional statement. That's from 1 and 3, ampersand, arrow out, 1 and 3. We can get rid of the T, so that would be from 4 and out. 3, got to the consequent we were looking for, so we can arrow in from 3 and 5, arrow in. 3 and 5 is 1 and 3. 3 drops out because we're doing the arrow in. And now we got both of our conditional statements that we were needing. So we can just double arrow in from 2 and 6, double arrow in. And don't need these other two. So that's it for 5. In 6, we got another simple or biconditional statement as our conclusion. So we're looking for P arrow T and T arrow P. And we might be in luck here because we have both of them already written in our premises. So we can get the P arrow T out from 1 and out. And we can also get the R out from that, doing the same thing. Now we can toss that R into our conditional statement in 2. So that would be 2 and 4, arrow out, 1 and 2. And now we got both of our conditional statements that we were needing in 3 and 5, so we can just double arrow in from 3 and 5, double arrow in, 2. Don't need the 7, so that's problem 6. So here on 7, we have a biconditional as our conclusion. So we're looking for both of these conditionals. Do we have either of them? Well, we do have the first one right there. So the question is, do we have the second one? Well, not yet. So that tells us we need to assume the left-hand side, look to prove the right-hand side. So we'll assume T as a PA, and then we can get P from 2, arrow out, or sorry, 2 and 3, arrow out. Then we can wedge in our Q on 4, wedge in. Now we've got to our consequent we are looking for. We can arrow in. So that's from 3 and 5, arrow in. 3 and 5, 2 and 3, but we drop out the 3 because we're doing arrow in. And then we can do our biconditional in. From 1 and 6, biconditional in. 6 have 1 and 2. Now this one's pretty similar to one that we did previously, so should be pretty familiar. But again, it's just looking for the conditional statements that we need. If we don't find them, we assume the left-hand side, look to prove the right-hand side. Now here on 8, we are looking to prove an ampersand. So we're looking to prove T double arrow S and S double arrow T. Now you might realize that the conditional statements that go into both of those are the same. So we would need S arrow T and T arrow S, and then we could build both of those, because that's what it takes to build both of these. We need the conditionals S arrow T and T arrow S to make S double arrow T and T double arrow S. So what we're looking for are these two conditionals here. And do we have them? Well, we do. We have one here, and we have one here. So we can get the first one by doing S arrow T from 1 ampersand out. And then to get the other one, we're going to need the P from 1 ampersand out. And then we can toss that into our conditional statement in 2. So that's 2 and 3, or nope, 2 and 4. Arrow out, 2 and 4. It's 1 and 2. Now we got the other conditional statement that we needed. So we'll make T double arrow S from 3 and 5, double arrow N. And then we will make S double arrow T from 3 and 5, double arrow N. Because you can make either one from our two conditional statements. Then all we got to do is ampersand them together from, looks like, 6 and 7, ampersand in, 1 and 2. Don't need 9. So pretty easy. Just had to derive both the biconditionals and then ampersand them in. Here on 9, we have another biconditional, so we're looking for P arrow Q, which we see here, and we're looking for Q arrow P, which we see here. So we're looking to prove both of those. We might be able to derive them from our premises, so let's just see what we can do with what we've got. Well, I can get rid of the P, and I can get rid of the T and P arrow Q from 1 and out for both of those. Then I can also get T and P arrow Q out from 4 ampersand out. Now I've got one of them. I've got the P arrow Q. I need to get to Q arrow P, and to get that I need the antecedent to the conditional statement in 2. So I can put P and T together from 3, 5, ampersand in. 3 and 5, it's both 1. Then we can get Q arrow P from 2 and 7, arrow out, 1 and 2. Now we got both of our conditional statements, and we can just double arrow in to get P double arrow Q from one conditional statement's in 6, the other one is in 8. So that is biconditional in and 2. So that's 9. Here on 10, we have another biconditional. We have S or P double arrow T or Q. So we need to find both of these conditional statements. And we don't find either of them in our premises. So that tells us that we're going to have to prove both of them separately and then put them together later. So to begin, let's assume S or P as a PA. And if we do, we can toss that into our second conditional or second line to get Q from 2 and 3 arrow out. Then we just need to wedge in our T from 4. Now we've got to our consequent we were looking to derive, so S or P, arrow T or Q from 3 and 5, double, or not double, just single arrow in. And so we would drop out the 3 because that's our PA, so that's one of them. Now we need to get the other one, so we would assume T or Q as a PA. We can toss that into our first line to get S. And so we can get S from 1 and 7, arrow out, 7. Then we can, just as we did before, wedge in our T, 8 wedge in. Then we get our arrow statement that we are looking to build from 7 and 9, arrow in. So since we are doing arrow in, we drop out the 7, and then I just need one more line here for 11 to do my biconditional in. From 6 and 10, biconditional in. 6 has 2, 10 has 1, so 1 and 2. There we go. So that's problem 10.